What if I told you there are planets in our galaxy so hot they can vaporize metal, and some may even be hotter than the surface of the sun? That sounds impossible, right? Planets are supposed to orbit stars, not outshine them in temperature. The sun's surface is about 5,500 degrees Celsius. That's hot enough to melt almost anything we know. So how can a planet, which doesn't even produce its own energy, compete with that? Here's the pattern interrupt. Heat in space isn't about who's bigger. It's about who's closer. Astronomers have discovered a class of exoplanets called ultra-hot Jupiters and lava worlds. These planets orbit extremely close to their stars, sometimes completing a full orbit in less than 2 Earth days. Because of this extreme proximity, their surfaces are blasted with radiation nonstop. Take KLT 9b. Discovered in 2017, it orbits its star every 36 hours. Its dayside temperature reaches about 4,600 Kelvin, over 4,300 degrees Celsius. That's nearly as hot as the sun's surface. In fact, it's so hot that metals like iron and titanium don't condense into solids. They exist as vapor in the atmosphere. Scientists have actually detected these metal gases using spectroscopy. Let that sink in. On this planet, iron floats in the air as gas. Now here's where it gets controversial. There is a planetary candidate called Kepler 70b, orbiting a hot subdwarf star. Estimates suggest its temperature could reach around 7,000 Kelvin, potentially hotter than the sun's visible surface. If confirmed, that would mean a planet exceeding the sun's surface temperature. But wait, if it's that hot, why doesn't it become a star? Because temperature alone doesn't make a star. Mass does. Stars shine because of nuclear fusion in their cores. To ignite fusion, an object needs at least about 8% of the sun's mass. Even the largest known planets fall far below that threshold. These lava worlds are being cooked from the outside, not powered from within. Now let's talk about rocky lava planets. 55 Cancri, located about 41 light-years away, is about twice the size of Earth. It orbits its star in just 18 hours. Its surface temperature is estimated at around 2,400 degrees Celsius, hot enough to maintain oceans of molten lava. Observations from space telescopes like Spitzer suggest its surface may constantly reshape due to volcanic activity and magma flows. Then there's Corot 7b, one of the first rocky exoplanets ever discovered. Its dayside temperature may reach about 2,500 degrees Celsius. Scientists believe it could have a permanent lava ocean on the side facing its star because it's tidally locked, one side always facing the heat, the other in darkness. And it gets even stranger. On WASP 121b, temperatures exceed 2,500 to 3,000 degrees Celsius. Water molecules in its atmosphere are torn apart into hydrogen and oxygen due to the intense heat. Some ultra-hot Jupiters even experience atmospheric escape, where stellar radiation is literally blowing their atmospheres into space. KLT 9b, for example, is slowly losing mass under extreme radiation. These planets aren't just hot. They're unstable. They're being stripped, reshaped, and in some cases, evaporated. And here's the bigger picture. We've confirmed over 5,500 exoplanets so far. Our solar system once seemed like the blueprint for how planets form. Small rocky worlds near the star, gas giants farther out. But these discoveries shattered that model. Nature doesn't follow our expectations. In fact, early Earth itself was once a molten world after its formation and the impact that created the moon. Lava oceans aren't alien to planetary science, but these exoplanets take that concept to an extreme that never cools. So yes, there are planets that can rival, and possibly exceed, the sun's surface temperature. Not because they are stars, but because they are trapped in a relentless cosmic furnace. The universe keeps breaking our assumptions. If you're fascinated by extreme space discoveries and mind-blowing science explained simply, make sure you follow for more. Now tell me, if planets can be this extreme, what other impossible worlds do you think are still waiting to be discovered?